बिस्मिल्लाहिर्रहमानिर्रहीम सल्लल्लाहु अलैहि वसल्लम अल्लाहुम्मा रब्बि ज़िदनी इल्मा सल्लल्लाहु अलैहि वसल्लम आमीन अल्हम्दुलिल्लाहि रब्बिल आलमीन. The topic of this lecture is important questions of type 1 and type 2 errors in testing of hypothesis. For this lecture, I am using the work of an outstanding, the most dedicated, and one of my best student, Miss Iman Anwar of class 2021, the Lyceum. An important advice for me and for everyone, we should be generous. Testing of the Poisson distribution. The number of accidents per month at a certain road junction has a Poisson distribution with mean 4.8. This is lambda. A new road sign is introduced warning drivers of the danger ahead, and in a subsequent month, 2 accidents occur. This 2 means the test value. A hypothesis test at the 10% level is used to determine whether there were fewer accidents after the new road sign was introduced. So H1 has a lesser sign. Find the critical region for this test and carry out the test. For critical region, we use trial and error method. This means same number of accidents, this means fewer accidents. The lower tail test. For critical region, do trial and error. So let x be 1, and this probability is less than 10%. This is less than 10%. So 1 is in critical region. Now check 2. Probability of 2 is 14.3, which is greater than 10%. So 2 is not in critical region. Therefore, critical region is 0 and 1. Since the test value is 2 and it is not in critical region, so accept H0, that means reject the claim. Type 1 error. This is the probability of critical region. And critical region is 0 and 1. So the probability to x less than equal to 1 or critical region is this. So this is the probability of type 1 error. Next question. The number of sightings of a golden eagle at a certain location has Poisson distribution with mean 2.5 per week. So this is per week for 1 week. A naturalist wishes to test at the 5% significance level whether there are fewer sightings. H1 has a lesser sign. He notes that during the following 3 weeks, so this is for 1 week 2.5, so for 3 weeks means 2.5 into 3, which is 7.5. So lambda 7.5 and test values 2. Find the critical region. So number 1, use trial and error method. 2, the probability of x less than equal to 2 is less than 5%. That means 2 is in critical region. Now check the probability of 3, which is greater than 5%. So 3 is not in critical region. So since 2 is in critical region, therefore reject H0 or accept the claim that lambda has decreased. State the probability. State why the naturalist could not have made a type 2 error, because H0 was rejected. When H0 is rejected, then type 2 error cannot be made. Part 3. Let me just give numbers. This is part 2 and part 3 is here. Because H0 was rejected. And you all know type 2 error occurs when H0 is accepted. We rejected H0, so type 2 error cannot be made. Next question. The number of injuries per month at a certain factory has Poisson distribution. In the past, the mean was 2.1 injuries per month. So 2.1. New safety per month. This is per month. Next 3 months. So 2.1 into 3, 6.3. whether there are now fewer injuries. So H1 has a lesser sign. Fewer injuries, same number of injuries. Critical region, again you have to do trial and error. So first try X1. The critical region is in lower tail. And the probability of critical is 5%, no, sorry, 2%. It's here. So this probability is less than 2%. So 1 is in critical. And this probability is greater than 2%. So this is not in critical region. So critical region is 0 to 1. And 2 is not in critical. And the test value is, what's the test value? Okay, just we didn't have test value. We don't have the test value, and we just need to find critical region. So critical region is 0 to 1. Now test value is given, and this is the probability of type 1 error. The probability of type 1 error is the probability of critical region. So part 2, I'm doing part 2 here. Probability of type 1 is the probability of critical region, and critical region is x less than equal to 1. So the probability is here 1.34%. 0.134. This is the probability of type 1 error. Part 2. During the next 3 months, there are total of 3 injuries. Carry out the test. Well, 3 is not in critical region. Since 3 is not in critical region, therefore, this is the part 3, answer of part 3. Since 3 is not in critical region, so accept H naught and reject the claim. Last part. Assuming that the mean remains 2.1, calculate an estimate of the probability that there will be fewer than 20 injuries during the next 12 months. This is the normal approximation. 2.1 into 12 less than 20 injuries, and lambda is 2.1 into 12. This lambda will be greater than 15, I guess. So you have to use the normal approximation here. X follows lambda, X follows Poisson, with lambda is this 12 into 2.1. So this is the normal approximation, and you have to do the continuity correction. I'm leaving the calculation for you. You can do this yourself. 19.5. So Z less than 19.5 minus lambda under root lambda. You have to do this yourself. Next question. Pieces of metal discovered by people using metal detectors are found randomly in fields in certain area at an average rate of 0.8 pieces per hectare. 0.8 pieces per hectare. People using metal detectors in this area have a theory that ploughing the field increases the average number of pieces of metal found per hectare. After they tested this theory and found that the random 3 hectares, 5 pieces. So 5 is the test value, and 3 hectares. So 3 hectares, you need to multiply 3 with 0.8. So lambda is 2.4 and lambda is greater than 2.4. Increases. This means greater sign here. Now, the test value is 5. Carry out the test at the 10% level of significance. So we have to check whether 5 lies in critical or not. So the probability of 5 is 9.59%, which is less than 10%. So 5 is in critical region. Therefore, accept the claim. H0 is rejected. So we have to accept H1. We have to accept this claim. Increase the average number of pieces. What would your conclusion have been if you had tested at 5%? Oh, well, if this was 5%, then this test value would not be in critical region. So we had to accept H0. 5 does not lie in critical region, so no significant increase, or accept H0. Jack decides that he will reject the null hypothesis that the average number of 0.8 pieces per hectare if he finds 4 or more pieces of metal in another plough field of area 3 hectares. So lambda is 4.2, 3 into 1.4. This is 1.4 is given. New lambda. Type 2 error. He will reject the null hypothesis if he finds 4 or more. That means 4 is in critical region. So type 2 error, critical region complement. So this probability must be x less than 4, because critical region is x greater equal to 4. And this is the new lambda. So this is the probability of type 2, the accepted region or critical region complement. When a guitar is played regularly, a string breaks on average once every 15 months. So 1 in 15 months. Broken strings occur at random times and independently of each other. Show that the mean number of broken string in 5-year period is 4. This is simple. You just need to multiply. You just need to check lambda. So 1 in 15 months. So 4 year means 12 for the 36. So 5 years means 5 year means 60 months. So 1 in 15. So in 60 it should be lambda. Just do cross multiplication. 60 upon 15, which is 4. You can do this in a ratio method as well. 1 in 15 months. So lambda in 60. 60 means 5 years. So lambda is 4 shown. A guitar is fitted with a new type of string which it is claimed breaks less frequently. So H1 has a lesser sign. The number of broken strings of the new type was noted after a 5-year period. The mean number of broken string of the new type in 5 years is noted by lambda. Find the rejection region for a test. So you have to do trial and error method. First try x1. This probability is less than 10% or 0.1. So 1 lies in critical. 2. This probability is greater than 10%. So you have to say that 2 is not in critical. 2 is in accepted, 1 is in critical. So critical region is 0 and 1. And this will be the probability of type 1 error. The critical region is this. And you know the probability of type 1 is probability of critical, which is this. The number of broken guitar strings of the new type in 5-year period was in fact 1. This is new lambda. State with a reason whether there is evidence. This is the new test value in fact. There is evidence at the Yeah, this is the new test value. State with a reason whether there is evidence at 10% significance level that guitar strings of the new type breaks less frequently. Since one is in critical region, so you have to reject H naught. You have to say, you have to accept the claim. Since one lies in rejection region, therefore H naught is rejected. There is significant evidence that the guitar strings breaks less frequently. Accept the claim. Yes, there is evidence at 10% that the guitar string breaks less frequently because one is in critical region. This is the new test value. Understand this thing carefully. Test value is 1 and 1 is in critical, so accept the claim. The number of severe floods per year in a certain country over the last 100 years has followed a Poisson with mean 1.8. Scientists suspect that the global warming has now increased the mean. A hypothesis test at the 5% significance is to be carried out to this suspicion. The number of severe floods X that occur next year will be used for the test. State the rejection. Show that the rejection region is X greater or equal to 4. This is so simple, you just need to get this probability X greater than 4. X greater than 4 means like numbers are 5, 6, 7 to infinite. So in Poisson, we find the probability in this way. 1 minus the numbers which are not in this inequality, in the list of this inequality. So this is the probability of the rejection region. Find the next part. Oh well, we had to show this that the rejection region is greater than 4. So this is less than 5%. Now we have to check whether 3 is in rejection region or not. X greater than 3, X greater than 3. So this probability is greater than 5% since 3 is not in critical and rejection region. So greater than 3 is not in critical, meaning X3 is not in critical and X greater than 4 is in critical, hence shown. The critical region is X greater than 4. Let me give you a short review of this. We had to show that X greater than 4 is the critical region. So X greater than 4, the probability is this. So we have to check whether X greater than 3 is in critical or not. Now this probability is greater than 5%. So this is not the critical. Critical is this. Which means critical region is this. Find the probability of making a type 2 error if the mean number of severe flood is now actually 2.3. This is the new lambda, the type 2 error. This is the probability of accepted region or critical region complement. So it should be X less than equal to 4. This is the probability of type 2. Make sure you use this new lambda here. Next question. A hospital patient's white blood cell count has a Poisson distribution. Before undergoing treatment, the patient had a mean white blood cell count of 5.2. After the treatment, a random measurement of the patient's white blood cells count is made and is used to test at the 10% significance level whether the mean white blood cell count has decreased. State what is meant by a type 1 error in the context of the question and find the probability that the test result in a type 1 error. Type 1 error means reject H naught when H naught is true. Decrease. Well, so H1 means no decrease and H naught means no decrease, means same, and H1 means the blood cell count has decreased. This is for H1 and H naught means no decrease. So H naught, Type 1 means rejection of H naught. So H naught, let me write H naught here. Lambda is same, or lambda is not decrease. Lambda has decrease. Well, type 1 means you accept this fact. Type 1 means rejection of H naught, meaning you are accepting this fact. You are saying, concluding that lambda has decreased when it is not. Saying that the white blood cell count has decreased when it has not. You are accepting this fact. Saying that the white blood cell count has decreased when it has not. Given that the measured value of the white blood cell count is 2, carry out the test. So we have to just check whether 2 lies in critical or not. 2. Since this probability of type 1 error probabilities, I forgot to solve this part in part 1. I just explained this part and find the probability of type 1. This is what we do through trial and error method. So we first need to check whether one lies in critical region or not, and the critical region is here. So check whether one lies or not. So the probability of less than 1 is less than 10%, so 1 lies in critical and 2 does not lie in critical because this probability is greater than 10%, this probability. So the probability of type 1 is this. 2. Now 2 is not in critical region, therefore accept H naught and reject the claim. White blood cell count has not decreased after treatment. Now the next part of this question, find the probability of a type 2 error if the mean white blood cell count is 4.1. This is so simple. The probability of type 2 is the probability of accepted region, and accepted region is x greater equal to 2. Is critical region complement, which is the probability of accepted region, which is x greater equal to 2. So this is the way to get the probability of type 2 error. Make sure you use new lambda. Always use new value of lambda. Next question. The number of injuries per month at a certain factory has a Poisson distribution. In the past, the mean was 2.1 injuries. I think we have done this question. Yeah, we just did this question, 41. Yeah, it's here. We have done 41. So I'm leaving this part, this 41. You can just check the answer of part 4. Lambda is greater than 15, so use this with continuity correction. And for continuity correction, always use number line. 19, so 19.5. Next question, 39. In the past, the number of house sales completed per week by a building company has been modeled by a random variable which has the distribution Poisson. Following a publicity campaign, the builders hope that the mean number of sales per week will increase. So lambda greater sign, H1 has greater sign. In order to test 5%, 3 weeks. So this is for 1 week, and for 3 weeks it's 2.4. Sales same, sales increase. it is assumed that a Poisson model is still appropriate. Given that the total number of sales during the 3 weeks is 5, okay, we have to check whether this 5 lies in critical or not. So x greater equal to 5 means this, and this probability is greater than 5%, so 5 is not in critical region, 5 is here. Therefore, you have to accept H naught. That means sales do not increase. You have to accept this thing, H naught, sales do not increase, or reject the claim. During the following 3 weeks, the same test is carried out again using the same significance level. Find the probability of type 1 error. So for that, we have to find the critical region. Type 1 is critical region. First check x greater equal to 6. Since 5 is not in critical, so we have to check whether 6 is in critical or not. So let me check whether 6 is not critical region or not. This probability is less than 5%. So 6 is in critical region. 6 is in CR. Therefore, probability of type 1 is this. Explain what is meant by type 1 error. Well, a type 1 error occurs when a true H naught is rejected, or you can say reject H naught when H naught is true. So basically you accept this thing. Reject H naught means you are accepting this. So you can say this, concluding that sales increase when it is not. Concluding that mean sales have increased when they have not. Type 1 error means you accept this fact. I mean, you just need to say concluding that the sales has increased when they have not. And type 2 means accept this fact. I mean, if I ask you explain in words what is meant by a type 1 and type 2 error in this context, then you would say, for type 2 you would say concluding that sales do not have increased when they actually have. State what other further information would be required in order to find a probability of type 2 error. A new lambda must be required. Value of new lambda. A new lambda is required. Testing of the normal distribution. From previous years' observations, the length, in this question, we don't need to work for type 1 and type 2 error, so I'm leaving this question. Here, we have to discuss the type 2 error. So I will only take those questions which involve type 1 and type 2 errors. The lectures in mathematics department are scheduled to last 54 minutes. And the times of individual lectures may be assumed to have a normal distribution with mean mu and standard deviation 3.1. One of the students commented that on average the lectures seem too short, so H1 has a lesser sign. This is mu, and H1 mu less than 54, meaning short lectures, and this means same lectures, time is same. Show that null hypothesis is rejected in favor of this. This is the critical region. You just need to show critical region. For that, use this inequality. When your critical region is in lower tail, we use this in inequality. So this is fine done. Find the probability of a type 2 error given that actual mean is 51.5. This is so simple. Basically, this is the type 2 error. So probability of type 2 error is this. This is part 2. Probability of type 2 is the probability of critical region complement or a probability of accepted region. Which is x bar greater equal to 52.74, because this is the critical region. So the answer will be z greater equal to 52.74 minus nu mu, which is 51.5 over standard deviation, which is 3.1 over under root 10. This is here. This is 3.1 over under root 10. You can do this yourself. You just need to evaluate this. Next question. A study of a large sample of books by a particular author shows that the number of words per sentence can be modeled by a normal distribution with mu and standard deviation. A researcher claims to have discovered a previously unknown book by this author. The mean length of 90 sentences chosen at random this book is found to be 19.4. This is the test value. And assuming part 1, assuming the population standard deviation is same, test at the 5% level of significance whether the mean sentence is the same. That means same or change. Same or change. So two-tailed test. Null hypothesis done, relating to the context of the test, and carry out the test as well. So the first part is this. We just need to check whether this test value, where is the test value? This is the test value, 7.3. No, sorry, this is the standard deviation. Test value is here, 19.4. This is the test value. So we just need to check whether this test value lies in a critical region or not. So minus 2.3392 lies here. So reject H naught and accept the claim. Accept this fact that mu has changed. State in words relating to the context of the test what is meant by type 1 error and state the probability of type 1 error. This is so simple. Basically, type 1 error occurs when you reject true H naught. A true H naught is rejected. So when we reject H naught, since we rejected H naught here, so that means you have to conclude this thing. Concluding that mu has changed when it has not. Whenever they say in words or in the context, explain what is meant by type 1 error. Always explain type 1 error with the help of this information. In this way, concluding that mu has changed when it has not. Saying that the mean sentence length had changed when it has not. Meaning mu, mean means mu. Mu had changed when it had not. And probability of type 1 is probability of critical, and which is always alpha percent in the normal distribution case. 36, the next question. The marks of candidates in math and English, normal distributions, and this is the equation. Expectation and variance, you already have done linear combination of normal variables. You all know how to find this thing. In mean, writes EX half EY, variance 5.6 square, and square this number 1 upon 2 square times variance. You all know how to do this. I'm leaving this part. Part 2. The final marks of a random sample of 10 candidates from Greenford in route 009 had a mean of 49. This is the test value. Test at the 5% level whether this result suggests that the mean final mark of all candidates was lower than elsewhere. We just need to check the test value whether this test value lies in critical or not. So Z test is minus 1.893 and 5% means, let me check why 5% is this, minus 1.645. So this number lies in critical region. So accept the claim. This is the critical region, 1.645 negative, and this value lies here. So you have to reject H naught. You have to accept the claim. that mean marks is lower. The mean final mark from all candidates at G is significantly lower than elsewhere. Next question. I'm leaving this question because I'm not discussing questions which don't have errors. So this question is not involving type 1 and type 2 errors, so I'm leaving this. And I'm leaving this question as well because no type 1 and type 2 error in this. So 18. People who diet can expect to lose an average of 3 kg in a month. In a book, the authors claim that people who follow a new diet will lose an average of more than 33 kg in a month. The weight loses are the 180 people. This is the sample size, this is the mu, and this is the test value, and this is the standard deviation. Mu has not increased, mu has increased. First part, 5% significance. So check this. This number is not in critical. Since this number is here, so you have to accept H naught and you have to accept this claim. Reject the claim. Reject that mu has increased. Is not in critical region, accept H naught, reject the claim. That is mu has not increased. State what is meant by type 2 error in the words relating to the context of the test in part 1. Well, type 1 error, whenever they ask explain type 2 error, so concluding that mu has not increased when it has. Stating that mu has not increased when it has. That is, there is no extra weight loss when there is. So always explain type 2 error from this information and type 1 from this information. Let me repeat this. Type 2 error. Concluding that mu has not increased when it has. What if they ask explain type 1? So explain type 1 from this information with the help of this information. Concluding that mu has increased when it has not. This means type 1. And type 2 means, this means concluding that mu has not increased when it has. This is so simple. I'm leaving this question as well because this does not involve type 1 and type 2 error. This one as well. Yeah, let me discuss this one. 83. In the past, the time spent by customers in a certain shop had mean 12.5. This is mu. Standard deviation this. Following a change, not equal, 13.5. Has changed. This change word means not equal sign. Assuming that the standard deviation remains same, this is the assumption we always use in the testing. Whenever we use the same standard deviation, here we assume that the standard deviation is unchanged. Change. So we just need to check whether this 13.5 lies in critical or not. This is the test value. Well, 1.684 and this is 1.960 critical region. This value is here. So we have to accept H naught and we have to conclude that mu has not changed. Another sample, state the probability of type 1 error. This is so simple. In normal distribution, the probability of type 1 error is always the probability of critical region. This 5% is here. Leaving this question. 88. In the past, the time in minutes taken for a particular rail journey has been found to be mean this 20.5. Standard deviation 1.2. Some new railway signals are installed in order to test whether the mean has decreased. Lesser sign. sample of 100, test value is this 20.3. So we just need to check whether 20.3 lies in critical or not. This is the test value z test, and this is 1 minus 1.751. So accept h naught because this does not lie in critical regions, so reject the claim. Mu has not decreased. Later, another significant test of same hypothesis, 100. Given that population mean is now 20.1, find the probability of type 2. This is so simple. Type 2 means probability of accepted region. Part 1, Part 2. Type 2 means probability of critical region complement or probability of accepted region. For that, we must work for critical region first. First, we need the critical region. Whenever they ask find probability of type 2, always find critical region first. So for critical region, Z test is less than Z critical because H1 has a lesser sign. So Z test, this is the critical region. Always use mu of H naught for critical region, 20.5. And in denominator we have 1.2 over 100 under root. And Z critical is 4% minus 1.751. So you will get the critical region. You should complete this calculation yourself. Then probability of type 2. This is the probability of X greater than the critical region. Write this number here. And then convert this in the form of Z. And use new mu. And the new mu is 20.1. Which is the actual mu. And the denominator is 1.2 over 100 under root 100. In this way, you can easily calculate the probability of type 2. Remember, whenever they ask find the probability of type 2, always work for critical region first and then get the probability of type 2. And write this value here. Now the next part. State what is meant by type 2 error in this context. I already have told you, always explain type 2 through this information. This means mu has decreased. This means mu has not decreased. So type 2 means concluding that mu has not decreased when it has. Concluding that mu has not decreased when it has decreased. So always explain type 2 with the help of this information and type 1 with the help of this information. Next question. Since there is no part of type 1 and type 2 in this question, so I'm leaving this question. 12. This is the frequency distribution. Make sure you will use this formula for unbiased estimate and this formula for the calculation of unbiased variance, population variance. So the formulas are here: sigma fx For mean, mu cap x bar sigma fx over sigma f, and the formula of variance is here. Part 1, calculate unbiased estimates, done, and use the exact value in later part, the largest value, the more accurate value. Null hypothesis, this has a reduction meaning less than sign in H1. So check this test value. So when you will check this, this is minus 2.519 and Z test is minus 1.645. So this lies in critical region. The critical region is here. Minus 1.645, and this value lies here. So reject H0 and accept the claim. There is significant reduction in the number of cars caught speeding. Number 3, state what is meant by type 1 error in words relating to the context in part 2 without further calculation. Okay, so always explain type 1 from with the help of this information, concluding that reduction in number of cars caught speed when there is not, stating there is a reduction in the number of car caught speeding when there is not, and this is the region of type 1 error because this is the region of critical region. I mean, this is the rejection region for H0. So the rejected region is the region of type 1 error. Leaving this question because nothing about type 1 type 2 error in this question. 47, a survey taken last year showed that the mean number of customer blah blah. So unbiased estimates, you already know how to find the unbiased estimates, sigma fx square sigma f, and the formula of mean is sigma fx over sigma f. Now test at 5% has changed, so check this test value. This is the test value, whether this lies in critical or not. 1.887 and critical is 1.96. This value does not lie in critical, this lies here. So accept H0 and reject this claim. Accept H0, no evidence that the mean number of computers per household has changed since last year. Explain what is whether it is possible that a type 1 error may have been made in the part 2. No, because H0 was accepted. When H0 was accepted, it is not possible since H0 is accepted. Because H0 was accepted. H0 is not rejected means H0 is accepted. Means the same thing. Not possible because H0 was accepted. State what is meant by type 2 error in the context and give the set of values of the test statistics that could lead to a type 2 error being made. Alright. So type 2, explain type 2 with the help of this information, concluding that mean has not changed when it has. And give the set of values of the test statistic that could lead to a type 2 error being made. Alright, for type 2 you have to accept H0. That means your critical value, for type 2 probability of CR complement, meaning accepted region. So the value, the possible values will be so z test should lie, between this range. This is the accepted region. This is the critical region. So this is the accepted. This is the region for type 2. So if the z test would lie here, from here to here, then type 2 error can be made. So the z test must lie between these two values. This is the answer of this part. Give the set of values. This question is important, especially this part. You can write this with the help of this sketch. Now the next question. First part, I'm leaving first part. Carry out the test. Mu is this. To test whether mu is 2.0. So mu has not changed, mu has changed. First find the unbiased estimates and then check whether this test value lies in critical or not. This does not lie in critical, so accept H naught and conclude that mu has not changed. Part 2. You may now assume that the population variance is this. The inspector weighs another random sample of 200. State the meaning of type 2 error in the context. Always explain with the help of this information. Mu has not changed. And this means mu has changed. So concluding that mu has not changed when it has. Concluding mu is 2 or has not changed when it has. Just write this. Concluding mu has not changed when it has. 2.12 type 2 error. Show that the probability. This is the two-tail test. A very lengthy question. Because first we need to find the critical region, and critical region in both the parts. This is the two-tail test. %5 each. So first work for critical region. In fact, critical regions. This is x1 bar. And this is x2 bar. So this is x1 bar. This is here. The value is 2.1582. and this value is 1.84179. Now type 2 error. Type 2 error means probability that x lies between these two. Let me do this in a different way. So this is type 2. So type 2 means probability of accepted region. And accepted region is this 1.84179 and the second one is 2.1582. So this number will be a new mu must be used 2.12. This is 1.84179 minus 2.12 divided by 1.85 200, 1.85 divided by 200. So this answer will be 0.652. So this is the easiest way. Probability of accepted region. So first get both the critical regions and use this formula for critical region. Z test Z critical. And after getting the critical region, after finding the critical region, find the probability of accepted region. This is the way to find the probability of type 2 error in two-tailed test of normal distribution. Normal approximation to binomial distribution. I will only take the questions of type 1 and type 2 error. There is no question of type 1 and type 2 error. Normal approximation to Poisson distribution. Now the last is binomial distribution to Poisson approximation. This is the last question of this lecture. Every month, Susan enters a particular lottery. The lottery company states that the probability P of winning a prize is this per month. Susan thinks that the probability is higher than this, meaning H1 has a greater sign. 12 lottery, this is N. She accepts the null hypothesis this if she has no wins in the year, accepts the alternative hypothesis this if she wins a prize in the least one of the 12 months. So this is P. Type 1 means critical region, and critical region is this. She accepts the null hypothesis if she has no wins in the year, and accepts the alternative if she wins prize in at least one of the 12 months. So critical region is this. When at least one of the 12 months means x is greater or equal to 1 till 12. So critical region will be this. So we just need to find this probability. So we can find this probability by using this formula 1 minus P0. Type 2. Type 2 means accepted region. Accepted region is 0. Probability 0. and a new p must be used. So 1 minus q power 12. Use a suitable approximation, repeat this, find the probability in 10 pairs period, Susan wins the prize exactly twice. So this is the Poisson approximation, and 10 years means 120 months, so 120 and this p. So lambda is this, exactly twice means x2. That's the answer. I hope this lecture will help you. This lecture help you to understand and the questions of type 1 and type 2 error, the way to solve the questions of type 1 and type 2 error. Think before we speak. This is the advice for me and for everyone. We should think before we speak, or think before you speak. Good luck. Allah Hafiz.